Yeah.
Okay.
Yeah, this is a map of not, yeah, it's written there.
Very pretty.
Like, yeah, can you please, like, from your perspective as a person that knows compilers pretty great, and yeah, and interpreters, to explain the structure from your perspective? Yeah.
So the original, I mean, so HNix has sort of evolved semi-organically. So what it was originally was simply trying to be an evaluator for the core language. So features like the REPL, that was not envisioned originally. And it was never trying to replace Nix itself. So there are certain things under effects like derivations that I'm not sure that was an original plan either. We kind of realized later into the project that we were getting close enough that we could replace the behavior of the C++ Nix. But originally it was about the language, the Nix language. So effectively imagine everything except the derivation strict function. And the reason being that the language is so close a mapping to Haskell's own evaluation model that it kind of seemed like it would be interesting to explore an implementation of Nix in the Haskell language. So that meant building up the expression type, the core expression type, and how we're going to now evaluate expressions into values. And there are other ways it could be done that are perhaps more natural. For example, there is a technique that Ed Komet talks about, which is called normalization by evaluation. And if we had gone that route, it would have been possible not to have a separate value type for evaluated expressions. Basically, what you do with normalization by evaluation is you make your expression capable of representing any value, and then you just evaluate back into another expression. I have some sample code from him on how to do that and what it would look like to do that in HNix, but that came much after I stopped being involved. A lot of the rest of this is all just supporting code for the expressions and their evaluation into values. Like rendering, that's all about pretty printing, which is sort of just support code. And those purple boxes you have all the way on the left, that was about wanting to write a type checker for Nix, even though it's not a typed language. So that's really Stefan Deal's code imported into the project to provide a Hindley-Milner type checker, which works surprisingly well. I was quite impressed to see how you do actually get decent type errors. All you have to do is you have to just tell HNix what the core type of all the built-in functions is, and then simply the way that you use those built-in functions on values will tell you what the types of those values need to be. What else is there in here? Frames was for getting better error reporting. And scopes is all about tracking data that's needed during evaluation. What else is there that's key? Fresh. I don't even remember what the fresh stuff does anymore. Oh, and then thunks, of course, because we're evaluating a lazy language, or a non-strict language, I should say. In order to provide lazy semantics in the evaluator, you have to have a concept of thunks to avoid the infinite recursion that either could occur, or also to defer evaluation of a thunk until it's actually demanded. And that was not trivial. Getting the thunking scheme correct was incredibly difficult. I think the majority of tricky bugs, the majority of time that was spent working on tricky bugs was working on getting thunking right. And then later we wanted thunking to be a configurable thing, because the way that the standard evaluator does thunking is just one way of doing it. but there could be other ways of doing it. And especially Ryan Trinkle wanted a customizable thunking scheme. So we created this monad thunk class that you implement in order to provide thunking semantics, lazy semantics, which then opens up the possibility of doing things like his idea was he wanted to have an interactive evaluator. So use HNix to present an expression in a web browser graphically. And then as you click on things, it would evaluate then and there and show you what the value it evaluated to was and how it resulted in doing that. But in order to provide that kind of interactive functionality, and he wanted to do it with his FRP library, what is that called again? Reflex?
Reflex, yeah.
Yeah. In order to do it with Reflex, he needed insight into the thunking scheme that the standard method didn't provide. So we came up with this monad thunk idea in order to allow him to do that kind of interactive thunking exploration, which I don't think that ever ended up becoming something that's publicly available, but that was the motivation. Just, this is really a library for tool builders. It's not a library for end users. So a lot of the complexity that's in this project is because there are a huge number of ways to customize the expression type, customize the value type, customize the evaluation procedure, customize thunking semantics. Like every single one of these data structures uses type variables to allow you to plug in custom behaviors so that you could have your own type of tool.
But yet I I recently had a lot of thinking about these things, and well, there are some things that are kind of hard-coded and very difficult to change. For example, if you look at the Thunk methods, it will take an action and wrap it somehow, keep it for later, and return another action. But so the basis is that it's always an action that you can force or execute to get the value. But there is no data, so you do not know what's the expression that will be evaluated, and you cannot extract the context in which it will be evaluated. So it's strangely obscure. Like we have a chance here to make a thing that remembers what expression will be evaluated and what is the context, and make all of these that information inspectable. And it turns out that the design decision is that it's an action, and as such, it's like non-inspectable.
It's interesting you say that, because there is actually support for getting full provenance of evaluation data. Like if a thunk evaluates, it can tell you where it got its input values from all the way back to the beginning.
Oh, indeed, there is this provenance thing that we could, okay, actually, I should look into that.
Yeah.
Well, that's a bit crazy because the provenance is something that's wrapped or like interweaved in the expressions and the values.
Yes, it's interwoven.
Yes, okay, I could.
I forget what the name of it
I
is
could
called.
I could look into that.
Let me see here. I forget. Is it called provenance?
Sorry?
I don't remember where
yes, something like that.
Yes, it's actually called provenance, right? And the idea there was, oh, right. So there's an option to take an expression tree and turn it into a cited expression tree. And then the cited expression tree for every single evaluation records what the evaluation was derived from and remembers it. And it ends up being information that you can get from the evaluator. Like if you run HNix and you say -- values, I think it will then report to you provenance information for the final value that it prints out. But there's way more information that it has in memory now than could ever be printed. I mean, if it tried to show you that information, it would overwhelm you. It would be a flood.
Yeah, it's crazy
because it's exponential, right? However, if we could have an interactive tool then we could hover a cursor over some, like if we saw the number 10, we could hover the cursor over it and it could show us, ooh, this was the result of evaluating 5 plus 5.
Okay, so that was one of the things I wanted to do with HNix. And so now I kind of get away, but these are like separate. And so we collect the same information at several places. But well, okay, that's fine. It's not the point of HNix to be super efficient. Well, at the moment it's super slow, but we could make it find a middle ground there. So well, I started with like a single ID. In Nix, there is a small optimization that just avoids making thunks around a single integer or a single string, stuff like that. Mm-hmm. And if you look at the abstract denotational interpreter, because we have this recursive structure and calls, at the moment where we decide that we want to thunk like the sub-expression, there doesn't seem to be a way to decide to either thunk it or not, because it's already an action that's already a black box. So maybe if we cheat with provenance and stuff like that, we could kind of re-implement the mechanism. But if you look at the eval function and the monad eval stuff, there doesn't seem to be any way at that place to like skip thunks for immediate sub-expressions. Does it make sense?
I think what you end up having to do, and this is what Ryan was doing, was that on the, let's see, let me take a look here at the value type. So if you look at the value type, the NValue F, it has these three variables, these three type variables, and one of them is M. And I'm trying to remember how this goes, because what you're describing sounds very similar to something that Ryan was wanting to do. Because in our in the source Nix Thunk directory, there is a basic.hs, which is like the basic thunking implementation that we're doing. So he had an alternate thunking implementation in where he wanted to preserve more information, but he didn't do it by putting anything into the provenance data. He did it by extending the functor that is used for value wrapping.
Okay.
It'd be interesting to ask him what that was.
Yeah, if something, then they, like, after New Year release that was made, when Layus contributed heavily to that release, they arrived with their code, the Obsidian system, and they almost completed it. It's in the pull requests, like the provenance changes they wanted to make. But it was not finished, and like I was rebasing their pull request for like a month or like months and a half, and writing to them, and they not responded. So like what I can do. What I can do at that point. Yeah, I cannot freeze the project because like they like almost delivered the pull request and like never finished, like, or and did not said to me like when, where, what. Well, like maybe like partially merged, maybe we merge it and like the project even stays broken, like, and we try to fix it like if it's really important, but like it's
so here's the type I was thinking about, Layus, which is this NValue prime.
Yeah,
and it takes T, F, M, and A. So T is the functor that you can use to wrap things for the thunking mechanism. So basically, by choosing a certain T, you can bundle up information that is consumed by your implementation of the monad thunk instance.
Okay, right. But so you would say that's basically everything, information we want to obtain, or well, any use case that we have should be implemented, or there should be a way to tune it using all of the parameters even there.
Yes.
Like we have a
Yes,
functor in
yes.
the type, and then we have a wrapper, like a monad in the evaluator, and stuff like that. And we should be able to stuff things into there, right?
Right, right.
That was the original design.
The original design was to give you enough higher order functor type variables that you could inject things that would wrap subvalues with whatever information you needed by the time you got down to that point in the evaluation. So
it still looks a bit strange for me.
Go ahead.
Yes.
And yeah, we also like, yeah, actually the line that I want to like ask question if like. Yeah.
So a value is a free structure, and it's free so that we can see how it was composed. And then it's free over this functor, this type T, which is the type of your thunks. So the leaves of your free tree are all these T types. And in the common instantiation of this, each of those T's is one of two things. It's either a fully resolved value, or it's a thunk waiting to be resolved. But since you define what T is, you can say, I want T to be something that carries more information, for example, like provenance details.
I wanted to ask about it because like the expressions lay on the recursion schemes nicely, but
Yes.
the value type, it has a free there. It has not fix. It has like instead of the fix, we have a free. Can it be somehow managed in like recursive schemes fashion? And is even the migration to recursion schemes because I have this idea, like it's what I can make, like.
So fix and free are related. Free is simply a fix over an either type.
Mm-hmm.
So a fix has no base case, right? It's pure recursion, which means that if you want to have a type that is not infinite in depth, you need to have a fix over a type that has base cases in it.
Yeah,
and provides the base case.
Yeah. It's basically, yeah, it has either inside it every time. Yeah.
Exactly. And so you can use both free and fix with data types that have been made for the recursion schemes approach. It's just, if you use free, you don't need to have a base case in your data type. If you use fix, you have to have a base case.
Yeah. Actually, it was one of my questions, and we got it arrived at the same line. Yeah, thanks. Great.
I've got to hop off, but thanks for organizing this, Anton, and nice to see you, John, and nice to meet you.
You too. See you, Greg.
See you around.
Happy to see you. So, Layus, how your name pronounced? Or
which one? I have no idea. For my pseudo, it's like it's kind of a random collection of letters that dates back when I was so young that
okay.
So any pronunciation is okay for me.
Yeah, my next question, if like with solve these ones, is the history, how it all started, like if you can skip the things that you already told like on Haskell cast, and like tell more about in depth how when the idea came when main work, like what kind of main work, what like study of it was, how many notebooks was written.
I think I just wanted to understand the Nix language better, and you really understand a language when you write a compiler or evaluator for it. And that did end up being the case. There are certain edge cases that are part of the Nix semantics that I don't think most people would know about, because you would never encounter them unless you had to write an evaluator. Like there are tricky interactions between the inherit keyword and the with keyword that might be very surprising, but it's like, you don't have to care. As a user of the language, you don't have to care. But as an implementer, you have to get it right. You have to do it the same way Nix does it.
Actually, it was it's one of the like to implement like bug to re-implement like Nix, like it was it's additional challenge. And do you have a style like of writing down things, or like reasoning about how do you reason about when you do this?
No, I think I just draft code. I mean, there's a lot of code that you don't see in the repository because I wrote it and deleted it, but that's probably how I explore my ideas.
Yeah. So, and how, like, again, like it basically the history of activity represented in the code base, or where is more comments, there is more activity. Like I mean mental activity, like primarily, because
I may not have even checked it in.
Yeah, I interested in the volume of like intellectual effort that it took. Yeah, because
that's a good question.
Because like I have currently like I need to ramp up my math again, like to it's mind discipline.
Yeah, certainly it was a good chance to really sink my teeth into recursion schemes, and I used it for that purpose too, to learn recursion schemes better.
And as I said, despite that, I like read recently and heard that recursion schemes sometimes like they do not have, or they like GHC regressed in recursion schemes several times after the Edward did an implementation, and it's, but actually its implementation of recursion schemes library code is really like classic. It's clean, like there is no unboxing, there is no like it's pretty straightforward recursion scheme code. Like it's maybe unoptimized, and like they like maintenance currently, like but it's really small library, and even if to port, I still think it's porting that to the standard library is beneficial, like even to again to refactoring the code, to making like one of my main agendas of this year and of work in the project up to this point was to make the code easier for people, so more people can come, they can understand the code better and write or like work with the project. Because I understand that I'm not one-man army. Yeah, I only have two hands, I can make so far, yeah, and my brain only goes so far. And like one of the most efficient things that I could do is like to work on the simplification, and recursion schemes porting to it. I also think that it would simplify the code dramatically in terms that like this is an algebra, this is this operation, yeah, this is number of standard operations, and it's go if you want to contribute, go like understand recursion schemes, please. And yeah.
Yeah. And I think also recursion schemes gets looked at as a complex idea or library when really this is just doing the same thing for types that fold does for lists, right? If you write a fold on a list, you provide a base case and you provide what you want to do for each element, taking into account whatever the previous, whatever was generated by the previous step in the fold. But you leave the recursion work to the fold function. And you never deal with that. You never think about that. So recursion schemes is just doing this for types too. A lot of times what you want to do when you're walking over a type is you want to think about what you're going to do at every point. You don't want to think about how you recurse over the type. And all recursion schemes is doing is taking the how of the recursion out of the picture and letting you focus just on what you're going to do at every step.
Yes, definitely. Yeah. Working with recursions is about working at the cases, not at the recursion.
Yeah. It makes you think inductively rather than programmatically.
Yeah. And one of my questions actually, like we arrived, is about abstracting definitional interfaces.
Interpreters, yes.
Interpreters,
yes.
Yeah.
So that's the same idea, but now for evaluators. Rather than your evaluator being recursive, now you call out the pieces of your evaluation.
And there is like AD allows to, like, basically, as I understood so far, is it allows evaluation to approach like the way Haskell works and compilation works influences the evaluation of HNix through AD. If like,
well, when you say AD, I think people may hear automated differentiation. That's not what it would be. It's like ADI, right? Abstract definitional interpreters. And the AD, the degree to which this code pulls ideas from ADI is very minimal. I mean, the little helper function that's in the utils module called ADI is like an incredibly simple function. All I want to do is I want to take an evaluator and then some other function, and I want to make sure that at every step of the evaluation, I then do this other function on top of it. So now I can interleave two things. And that makes evaluators composable, because now I just keep nesting of interleavings of evaluators, and I get now a toolbox where I get to mix and match the same way that recursion schemes lets you do for type recursion.
Yeah. But I still need to conquer recursion schemes, and then I would arrive to ADI. That's why when Layus talk about like dismantling ADI, like, no, I should learn it first before I understand.
Well, but it's frustrating because sometimes like this ADI stuff, it's so pure and perfect, and it looks so nice, and well. I like it too, but it also has this issue that, for example, if at some point you want to know what's the remainder of the expression, like I would like to just look at the next one. Like, for example, if you take the eval function on the list, I don't know if you can easily find that. I cannot share my screen, but well, if you can find this eval function,
multi-share basically enabled. So.
Go ahead.
No, I just well, I'm not sure. I will try, but no, not working at the moment. Still missing some configuration for it to work. Anyway, when you have a list, basically you have to thank all of the elements of the list, and I was like, if only I could know if it's an integer or if it's because the way it's written, it's like one step of the evaluation, and the abstract interpreter just replaces all of the sub-expressions by the value, or like an action that computes the value. So it's too late at that time to just inspect one step further on the AST. All you know is that you have a list of already been evaluated somehow. Do I make any sense?
You kind of froze
so
up
I've looked in other.
Yeah,
Okay, I
there
I
was
will say
transmission.
differently that I went to. Okay, not much I can do about that.
Maybe try to
So
light up the room. It helps in color if something. Also.
Okay, right.
So you were talking about the thunks of a list.
Yep, at the time where you are evaluating the list,
Yeah.
you
Oh no, he froze at the same point.
only the elements of the list. No.
You can go to the audio if you want for like. Yeah.
I can stop video. I'm not sure if it will help, but
I also.
who knows? Okay. So, but basically, at this point, the interpreter is let's say like a catamorphism. So you replace all of the subparts and that's it. And so I wanted to change it a bit, tune it. So like it looks more like a paramorphism. So you also get the evaluated expressions at the same time as the result of the evaluation. And that kind of works, but then it's like everything's become more complex. So I'm not sure what's the right way to go around that, but it adds a bit of complexity because, well, if you look at the code of NEx, for example, they don't have to write things one layer at a time. It's just like they are picking at the next layer and they look, oh, it looks like that. And then they come back and they can, well, they make a lot of changes that are not purely recursively defined. So, well, I'm not too sure. At the moment, I feel it's more like a pain, but maybe we can make it very nice in the end.
I would recommend or like write more because like in the project the most frequent that I get is like one-liner from somebody and I like should infer all the meaning like that what you are talking and yeah. Maybe.
I made a lot of different trials, so maybe I should open like well, store them somewhere in the project so that they are available, even if it's not perfectly working or not completely working.
Yeah, and yeah, that's as I stated several times that I currently want to like start closing the API to have easier time moving everything, like moving the modules, like understand what is used inside the project, move the modules, organize them, preparing to the package split, and write like everywhere in the modules that if you want some functionality, please like write. It's not there is no problem to open functionality that is already there. Like we would know basics what should be provided, but we also like it's from my point of view, if like it's known that having an export list allows compiler to compile, easier time to compile and optimize sometimes much more if not everything is exported. And in some modules we have like managed exportation, but a lot of modules like on the outer layer is like completely open. And it also has, I have like, if not to write a changelog, it's like okay, I can make all those changes and you would need to like debug why it's there. Yeah. And but if to maintain the changelog, it's the size of the changelog and amount that the users would be bothered with with all these changes is like correlate to the IP size. So that's why I also have this idea. And basically the splitting of that's also like John mentioned, that many of this code, for example, linter I think it's if maybe like it almost it does not used as and some subsystems definitely like there is a lot of dead code.
Yeah, it could be a separate project easily.
Yeah.
I just noticed this one thing, Anton, I wanted to mention.
Yeah.
You have this transform type that's defined in terms of this transform F type.
Yeah.
So the comment on transform F says that it's a transformation between functors, but it's not. Transform F is not a functor in this type variable. So transform F should probably be called maybe something different and just take type variables A and B. Because what transform F is doing is that you have a function that reduces from some type to another type, and you're going to provide a substitution for that reduction with another, if you look at how transform F is used elsewhere in the code. But it's just one thing I noticed.
Yeah.
So a transform.
Strange, but if you look at the definition,
Go ahead, Layus.
if you look at the definition of ADI, basically you get a fairly good idea of how it works and what it does.
Right.
Because it's
so
basically
a
wrapping up
transform,
afterwards.
a transform rather than a transform F, there F is a functor, right? Because a transform is something that it takes a function from fix of F to A, so a reduction, and it replaces it with another fix of F to A. And that's going to be this G. And then F is our algorithm, the standard recursion schemes algorithm that you would apply using a catamorphism. And then what ADI does is it says F is applied to every element in the tree, but then G has a chance to change the result. Like it has a chance to change how F does its job at every level. And then this recurses. So you basically have this G is like it's like an infection, right? It's taking a catamorphism using F would have been one thing, but an ADI G of F allows G to go through the entire evaluation structure and alter what F does, like change the character of F. And that is how ADI is used to do things like inject debug statements throughout the evaluation process.
With F, there's definitely I took liberties in naming, like, because I basically made because it's not fixed and transform is fixed.
Right.
That's
so a
why
natural transformation, just for your info, always has this form that I'll put into the Zoom chat. Like you have two functors, F and G, and it's higher order, so it's quantified over some universal that is hidden from the user. And the natural transformation says anything you have that is in some functor F, I can change it to be in some functor G. And the for all X is why it's called a natural transformation instead of just a transformation. The universal, the hidden universal is the naturality condition of the transformation.
Yeah, actually, I think that Bartos does not put for all there.
So it would look like this,
because naturality he like shows as F of X to the G of X.
Something like that. Like if it were to be encoded as a type, you may have to use data in order to hide that universal, but that's just the general idea.
Can you elaborate on use, like, as I understood that ADI does not involve in like a runtime process from the like does not borrows from the nature of like or power of the compiler, but recursions.
No. ADI really here is just an abstraction of a technique to do this function wrapping.
Because when I started to read like to skim papers. That's like what I observed, and like the description, like and can you touch upon recursion schemes inside GHC? Maybe.
No, I'm not familiar with that.
Okay. Yeah, I mean, like optimization. Yeah, I read about the fusion of them, and like recently I read like Kmet comments that if to build hylomorphism, it does not optimize, and if to use fold build pattern and unfold destroy, I think, or something like yeah, it's would be basically the same thing, but it would be optimized, fused, like all the there is much to learn.
Always.
What I can say. Maybe some suggestions, like I wanted to, yeah, maybe I'll stop recording.